Hey everybody, I'm getting around to doing the video for the write-up for the rate law lab. And so this may be a little bit longer, but I think it's good for you to have some guidelines and some idea how to make the graphs and interpret the graphs and go from there. So before we get started with the write-up, I do want to say, remember that the purpose of this lab was to determine the rate law and the rate constant of the reaction between iodide ion and the peroxysulfate ion. Okay, and so iodide ion, let's bring that up. The iodide ion, remember, is I minus, and the peroxysulfate ion is S2O8, 2 minus. And those two things react to create a color change. Okay, so the data for this lab looks kind of like this. Okay, so this would be one experiment here. Okay, and you had 4 experiments, so you're going to need 4 of these data tables that have the time between each color change, the cumulative time, and then the total moles of S2O8. Okay, now where did I get the 0.0002 from? That's a legit question. If we look in the lab, okay, it says right here, for reasons to be explained shortly, the solution will turn blue-black when 2 times 10 to the minus 4 moles of S2O8 has reacted. Okay, so that is where we get 0.0002. So every time you're adding that, the test tube, that's telling you that we have reacted 0.0002 more moles of the S2O8 in the reaction. Okay, so that's the whole kind of, I don't want to say the point of the lab, but that's how we collect all the data. Okay, so this data here should be, in this data table, should all be pretty easy to get. You should have already gotten this information. And this column in particular, you should just get for each, that should be the same for each experiment. Okay. Now, the point of this lab, not the point, but what we're ending up trying to do and calculate is to get this table here that is kind of like a methods of initial rate problem. Okay, we did 4 experiments. Okay, we called them solutions in the lab. We had solution 1, 2, 3, 4. And this data up here goes to determining what the initial rate is. Then we have to calculate what the initial concentration of the peroxysulfate ion and the iodide ion are, which we can do fairly straightforwardly using the dilution formula, M1V1 equals M2V2. And then once we have that information, then we can do a method of initial rates problem to determine the orders of the reaction. So maybe we should write out this. So the first thing that we have to do is plot moles versus time for each reaction. The second thing we're going to do is determine what the initial rate is based on that plot. The third one is to use the dilution formula to find the initial concentrations. The next one is to fill out the method of initial rates data table, which is this thing right here. And then the last step is to actually do a method of initial rates problem. Those are the 5 things that we are doing in the write-up to get to the actual answer that we want to report. Okay. This data from the lab you should have. Now, what we're going to do is we're going to take this data, cumulative time versus total moles of S2O8 2-, and we're going to plot that. Okay. we're going to plot that, making sure that time is on the x-axis and total moles is on the y-axis. So to plot that, I'm going to highlight these two columns, and I'm going to click here, and then I'm going to change the chart type to a scatter graph. Okay, and then part of that scatter graph, notice the x-axis is time, and then the series, which is the y-axis, is the total moles of S2O8. Okay, and then we come to customize, and we look at the series, we give it a trend line, we know that it's going to be linear, and we're going to give it the label, we're going to use the equation to label it. Okay, now here's the graph. Now with the graph, this here is the equation of the line. Remember, it's y equals mx plus b. Okay, so now for this, it's not anything that we need. We don't need to plug in values here. We need this value. We just need this. This is the slope, and the slope of that line is almost equal to the rate. Okay, so once you have that, the slope, 1.35 times 10 to the minus 6, that's in moles per second. Okay, the y-axis is moles, the x-axis is second. What we have to do then is divide this by the volume, because we want moles per liter second. So we're going to take this whole thing and we're going to divide it by 0.1 liters. Okay, because remember, our solutions were all 100 milliliters. Right here, we added 25 milliliters to solution 1 and 3, and we added 50 milliliters to solutions 2 and 4, for a total for each experiment of 100 milliliters. So when we do that, we get that the rate, the initial rate is this, molar per second. Okay, so that is what we're going to do for all four experiments. And then that goes into here. You'll do that for each one of those. That's where we get steps 1 and 2. Okay, you're going to do that 4 times. Now we need to find the initial concentration of S2O8, the peroxy sulfate ion, and the initial concentration of the iodine ion. And that's not too horrible. So let's call up the actual lab handout. And you'll notice that in the lab handout, that the amount of peroxy sulfate we used was 0.2 molar, and iodide in the form of Ki is 0.2 molar. That's what we used out of the bottle. And then we mixed it with stuff and it was diluted. Okay, so we're going to go down to where the solutions were. Past it. Okay, and you'll see in this first solution, we used 25 milliliters of Ki. Okay, well, 25 milliliters of Ki, our initial concentration was 0.2, and then the volume that we used was 25 milliliters. Now we're solving for our actual concentration in the thing, in the solution, and we diluted it to 100 milliliters. So this is molarity, this is milliliters, this is molarity, and this is milliliters. Okay, so when we do that, we basically are diluting it by 4, so we get a new molarity, M2, of 0.05. For Ki, that's 0.05, 0.05. And then we can do the same concentration, or the same thing, for peroxysulfate. Peroxysulfate in experiment 1, look right down here, 25 milliliters. Okay, and that changes for each experiment, right? And so look down here, it says it should be treated the same manner, except that 50 milliliter portions solutions should be added. Okay, so we have to make sure that you read all of this. Okay, for S2O8, the peroxysulfate, again, we have M1V1 equals M2V2. And so the initial concentration, or sorry, the original concentration out of the bottle was 0.2 again. And we used, for that experiment, 25 milliliters. We want to know what the new molarity is, and the new volume, again, for each of the experiments was 100 milliliters. So the math works out to be the same, but we all know that the math is not chemistry. So this is definitely still 0.05 molar, but it's 0.05 molar S2O8, 2 minus 0.05. And for each of these, you're going to have a slightly different, you could have a different value. Remember, the whole point of doing a method of initial rates problem is that some are going to be the same, some of the concentrations are going to be the same, and some of the concentrations are going to be different, so you can compare them and do the math. Okay, so once you have this all filled out, then you can actually do the method of initial rates problem. So I've taken the time here to show you how this works. Notice in experiment 1, or in solution 1 and 3, the initial concentration of S2O8 doesn't change. And in experiment 1 and 2, the concentration of I doesn't change. Okay, so that way you can compare them and cross them out and use them. Okay, the one thing that I want to say, okay, we've made it this far into the video, the very end here, is that because this is actual experimental data, the experimental data isn't going to give you exact good whole numbers. Okay, so when you figure out what your powers are, okay, when you figure out what the orders are, and if they are, let's say you get an order and it's 2.2, okay, that order means that it's more than 2, so you have to round up to the next, that has to turn into 3. Okay, orders are never decimals. So if you get something like 0.3 as your power when you do the math, you know, that has to go up to 1. It's because the experimental information is going to be off, and you guys, however awesome you are, you weren't perfect. So make sure that you keep that in mind, that you can't round down, it's always rounding up to the next value. Okay, so by the time you get that done, you should end up with not only the rate law, but also being able to determine the rate constant. Okay, so that's how you do the lab, or that's how you write it up. You're going to have to then come up with conclusions, and the conclusions are based on the math, so that's cool. But there it is. Okay, have a great day.